1,200 students at Pine Elementary School. In the year 2010, there were 1,500 students. Find the rate of change from 1995 to 2010, and then model the data with a linear function. Let x equal the years and y equal the number of students. Then predict the number of students that will be at the school in the year 2020. So this problem has three parts. First, we want to find the rate of change. So let's look at our quick guide. Our average rate of change means find the slope. Now, in order to find the slope, we must have two ordered pairs to use the slope formula. Now, we don't see those ordered pairs in this problem, but we can create them from the information that is given. So if we look carefully, in this sentence, it says let x equal the years and y equal the number of students. So x is years and y is students. Let's look at the first sentence. In the year 1995, so we have a year here, 1995, there were 1,200 students. In the year 2010, there were 1,500 students. So we have another year, 2010, and another group of students, 1,500. So we have x, y, x, y. These can now become our ordered pairs, our points that we can use for our slope formula. Remember, the slope formula is y2 minus y1 over x2 minus x1. So let's label these points, x1, y1, and x2, y2. Our next step is to use our slope formula and plug in. So y2 is 1,500 minus y1, which is 1,200, all over x2, 2010, minus x1, which is 1995. Simplifying that, we get 300 divided by 15, which gives us 20. So our rate of change is 20. So that's 20 students per year. Notice we have y values on top and x values on bottom. Y values is students over years. The next problem the next part asks the linear model. Looking at our quick guide, the linear model means find the equation of the line. And we're trying to find that in slope-intercept form. So in order to find the equation of the line, we cannot go directly to slope-intercept form. Similar to other problems, we must use our slope and one of the points. So let me section this off, and we're going to use y minus y1 equals m times x minus x1. And if you remember correctly, this is point slope form. So we're starting with point slope and we're trying to find the equation in slope intercept. Again, you can use either point. I'm going to use the one that's already labeled x1 and y1, and we're going to use the slope of 20. Let's plug in. Y minus y1, 1,200, equals m, which is 20, times x minus x1, which is 1995. So our next step is to distribute. So let's distribute the 20. Y minus 1,200 equals 20x minus 1995 times 20. So that's 39,900. And again, we're trying to solve for y. So we're going to add 1,200 here and add 1,200 here. This is going to give us y equals 20x minus 38,700. So this is the equation of the line, which is the same thing as linear model. So this is our linear model. Okay? So our linear model is, let's plug in our blank here, 20x, notice it already has the y equals 20x minus 38,700. Our last step is to find the number of students in 2020. This says predict. When we see the word predict, that means to plug in a value for x into the equation we just found. So our value is 2020. We're using that to plug in to this equation for x. So I have y equals 20 times 2020 minus 38,700. And let's see what we get. So we have 20 times 2020 minus 38,700, and I get 1,700. Now this is in y, so 1,700 is the number of students the school is predicted to have in the year 2020.